Uh, hey, looking in the mirror here. Hi, everybody. I think this is going to be what 30 to 61. I'm going to try to cover that before class starts at 9 this morning. I do want to thank all of you who sent in reflections. I wish I could have responded in greater length, but some of you I see quite often, and the help, I didn't bother saying anything. I'll talk to you in person in help sessions. But, just a couple of quick thoughts back your way. And it was appreciated just to hear from you because of our lack of social contact. So, all right, let me get these problems out of the way, and just going to remember, pause the video if you think you got something wrong, checking that answer key that I'm creating at the same time so I don't have to do it during a faculty meeting. I didn't hear anything back, so I guess I didn't have anything wrong on it. I can't believe that, as you finding out for yourself when you're working with volume, lots of problems. It takes a great deal of concentration to not make those careless errors. So none of us is really doing that because time constraints, and I understand that. I understand it for myself. I understand it for you. Do the best you can on this test, and let's get at it. All right. Very common SAT problem. So we're going to do f of a plus 3, and then we're going to put it in the g function and add 7 to what we get. So a plus 3 is going to get squared. Hope I'm writing big enough. Minus 3 times a plus 3. And that's now been put into f. And when we put that answer into g, we might as well put the plus 7 there right now. So we got a squared plus 6a plus 9. I'm going to put, because of space here, I'm going to put the minus 3a underneath. And I'm going to put the minus 9 underneath. And then I'm going to add 7. And that actually helped me out because that canceled. And so we get a squared plus 3a plus 7 as an answer. That's called a composite. This here is called a composite. Now, you might have seen it on an SAT as written as g of f. And sometimes they don't even put this in parentheses. So hopefully, if you see that, you recognize it. Okay, we got a difference of 2 squares here. We got ourselves a 5x squared plus 6y and 5x squared minus 6y. Okay, limit problem. I just snuck it in here. So we're getting good at, I think, squaring a binomial, right? So the limit as h goes to 0. I can't plug 0 in here right now because it's undefined. So let's see if there's a way to get it from undefined to a defined calculation for that value. So that's x squared plus 2xh plus h squared minus x squared all over h. I'm going to have to do this with the help of the eraser. So that's x squared minus x squared is going to cancel. Anytime you see a letter in 2 terms, your brain should go, oh, let's write that as a product. Why do you want to write it as a product? Because you got a division problem, and multiplication and division are inverse operations, and that's what allows us to simplify fractions. So I'm going to take the h out. H times 2x plus h brings me back to what I had a moment ago. Oh, this is very nice. The h's do divide out of the problem. Now I can let h go to 0, and the answer to this is 2x. Okay? Setting you up for some calculus concepts. What you really had at the beginning was y2 minus y1, x2 minus x1, where you were looking at the x squared function. At some x value, you squared it, and at some value slightly bigger as h goes to 0, 0.1, you get x plus h squared. And that was the subtraction in the numerator. That was the subtraction in the denominator. And that answer is the rate of change of a quadratic. Area of a quadratic, there's a square. Watch that area get a little bigger. X, just got a little bigger. And if we had a big square, it'll get bigger faster for the same length of the width of that marker that I just used. All right, so we should be able to rely on just getting a problem right, not thinking about it conceptually at this stage. We're going to subtract 7 and get 4. We're going to divide by 4. We're going to get 1. We're going to undo ln with e to the 1, and then we're going to add 3. So 3 plus e is an exact answer. 2.7 plus 3, roughly 5.7, if we wanted to do a graphical analysis. Asymptote of 3, right? Gone up, height of 11. Okay. I'm going to divide everything by 7 just to make life easy. I don't like to work. So therefore, x minus 7, x minus 3, x plus 2. Excuse my mistake there a second ago. So 3 and negative 2 are the answers to, they're the roots of this quadratic right here. But I don't think that was the way it was originally written. So wanted to see if you spotted a perfect square here. A minus 5 squared minus y squared. It's not the first time I've given you this problem. Done it a couple of times in class and on the board, and on a worksheet. So this is a plus 5 minus y time, a minus 5, my fault. A minus 5 is getting squared. So there it is. There's a minus 5. That's getting squared. And then you have I like the plus first and the minus later. And that's your difference of 2 squares. So there's your first term, call it n. And this is n. So n plus y, n minus y. What was n? A minus 5. Okay? All right. Another possible problem on your way on an SAT achievement test. All right. So let's see. We'll check our answer here. 25 minus 30 plus 9. I want to know what my remainder is before I do it. So I'll do the easier part first, then the harder part. If they don't match, well, then I got to do this part again, or that part again. So minus 5 plus 9, minus 5 plus 9, I should get a remainder of 4. So x times x gets me the first term. Minus 5x to get to minus 6, I got to go down 1. Minus 5 to minus 1 is positive 5. How do I get from 5 to 9? I have to add 4. Matches up. Continuing on our journey. You know, we got a severe weather warning today. Possible tornadoes. We might have to go because that house could go flying up today. All right. 2 7s and 3 5ths on the last test. I hope people made some gains. Therefore, 7x minus 2 is a factor, right? If x equals 2 over 7, if I want to make a 0 on this side, I bring the 7 over, and then I subtract by 2, bringing me to here, and that would get me 0 on this side. All right, if you solve for that, you got 2 7s. Forwards and backwards, forwards and backwards. So 5x minus 3, that's our function that has those as roots and the factors expressed with no fractions. All right, so 38. Moving right along. X minus 2 plus 5i, x to minus 2 minus 5i. I let a couple of problems in between what we talked about a moment ago. Do you see x minus 2 times x minus 2? That means that's x minus 2 squared. And this is minus 25i squared. Okay, that's the fast way to do that multiplication. Wanted to see if you saw that pattern. All right, so what is it? It's x squared minus 4x. This is going to be plus 4. That's going to be plus 25 plus 29. Square root of x. But I'm not measuring from 0. I'm measuring from negative 4. So therefore, let me make this bigger. Measuring from negative 4 gives me an x plus 4. And I want 7, right? And the square root of 0 is the smallest square root you can have. So I just got myself a starting point. I want to go from 7 to 17. I got to go up 10 units. And when I put a 2 in here, I got to cancel the square root of 6. So there's your answer for that one. That's the function. Okay? We're doing pretty well with that. I hope it means a little bit more to each time we do it. Square roots. So I can see the square root of 25 times 2 times a times b to the 10th squared times c to the 9th squared times c. Not that you have to do all of that, but in case somebody's struggling with this, so we can take a 5 out. We can take b to the 10th out. We can take c to the 9th out, because those are squares. What's left inside the square root is a 2, an a, and a c. Okay? Let's look at this graphically first. Where does it start? Negative 1/3. and it's going up at a three times faster than the regular square root, so it's going up. What's x minus 1? Well, our y-axis is to the right of -1/2. -1. Okay, so I now know that only has one answer, so I don't have to check both answers. I got to take the answer that's furthest to the right, and the one here is fictitious. Fictitious. Fractious. That's a great math term, huh? Fractious means troublesome. That's an easy one to remember if you had trouble with fractions growing up. Oh boy, back to the word of the day. All right, so we square both sides. I hope this thing has an integer answer. The last time I did this, I think it was nasty. X squared minus 2x plus 1. Hope you're not making mistakes on that. So we got a 0 equals x squared minus 5x. Oh, this is so sweet because the 1's cancel here, huh? So that's easy. So x equals 0. Well, I got to factor it, make sure everybody knows. So x times x minus 5. 0 or 5, and we know that that 0, it didn't work. In fact, it was a great intersection on the graph I did, right? Because I actually went right through. We can see that that was where, well, anyway. I got lucky, probably. Who knows? I'll go look at my own video. Maybe I'll learn something. All right, so we got a cube root. So let's do this with the help of the eraser. The cube root of 8 times 4 is a good way to think of 32. X, y to the 10th 3 times cubed times y. Okay, so now I'm going to do the answer above the original problem. So I can take 2. The cube root of 8 is 2. I can't do the 4. I'll come back to it. I can take y to the 10th out. And that's it. So now it's the cube root of, what did I say? 8 and 10, that came out. So I got 4xy. Okay? Standard question. So x to the 7th to the 0.5, I'm going to call 0.5 a half. Okay, so I now know I have the square root of x to the 7th. And the square root of x to the 7th is x to the 3 times the square root of x. That kind of looks like a root. So I'm going to move this over here a little bit. Maybe I'll even put a dot. That seemed confusing with the 3 because I don't want it to be confused with a cube root. All right, square root, we've gotten real good at this. Square root of 49 is 7. I'm not sure you know what 7 cubed is. I'm not sure I do either. I think it's 1 over 343. 7 times 49, 280 and 63, yeah, 343. I could be wrong. I'm pretty sure that's right. We'll find out. Mail me the right answer if I'm wrong. All right, 125 to 1/5. Maybe you can see a cube root flipped. Maybe you can see that. But if you can't see that, then you want to write 125 as 5 to the 3x and 1/5 as 5 to the -1. Now we can see 3 times x equals -1. And there's your flip, and there's your cube root. Okay, maybe you don't even have to do this out anymore. That would be nice to see it conceptually. All right, so we said we can move the 2 into the power to power position, which is multiplication, right? 2 to the 4. We're really looking at that concept with that mechanics. We're not looking at the whole problem. Well, maybe we are because of the base here. Hard to explain this. It really is. We can move this 3 there. It's just going to be the same answer. And so now we've got one big logarithm where addition is multiplication. I could move this over here, right? If I have 3 minus 2 plus 9, I could have written that. I could have written that as 9 plus 3 minus 2. Okay, so the addition implies multiplication. So a squared, d cubed. Subtraction implies division. Okay. If I had more time, and I don't want to lose track of this video, taking too much time, I would do something with LNs where you knew the numbers and you could see that work out. Happy to do it during a math help for somebody. All right, so I broke this up into the y column and the x column. I'm looking at the y column. I'm looking at an asymptote from 0, which means everything gets measured. Everything gets measured from 0. Okay? So what's my first jump from 0 to 10? 10 units. Now, I've done that. What's my jump from 0 to 20? Well, it's not 10 units, it's 20 units. We can already see the doubling. All right, I'm done with the y column. I'm looking at the x column. I'm not measuring from 0, right? I mean, I need a 0 here, yes? Something to the 0 is 1 times 10 in order to get that. But I'm using the number 5, hence the statement x minus 5. And then we have to look at the change. How often am I doubling? I'm doubling every 6 units. Okay? I'm going to do the same thing with the next problem, except I'm not measuring from 0 anymore. I'm measuring from 3. Excuse me. So I'm measuring from 3. So I want to go from 3 to 10. Well, that's a jump of 7. The next one's not a jump of 7. The next one is from 3 to 20. That's 17. Now, that's more than doubling. 14 over 17. Is a little bit more than doubling. Now I turn my attention to, the same numbers? No, I went from 6 to 11. So x minus 6 and 6 to 11 is every 5 units. The preceding altitude is 2 3/7 bigger every 5 units. And I'm starting the measurement from 6. All right, triple at 5%. ln of 3 over 0.05 equals 1.1 divided by 0.05. Multiplying by 100 makes 110 divided by 5, which is about 22 years. Now, it won't take any shortcuts. This is the amount of money you get depends upon how much money you put in the bank, and e to the 0.05t. I gotta make sure you can see this. I think you can. All right, so if we triple, this is going to become 3p. And if we divide by p, this is going to become 3. And then e to the becomes ln of. And then you divide by 0.05. And we're back to where we were a moment ago in the video. Okay? So what if I wanted to double at 7%? Well, it's going to be ln of 2, 0.07. So what if I wanted to quadruple? Well, I have to go to the calculator unless I got some feeling for, those. I think most of you do. It's squaring e to the 0.7, so 1.4. But these calculations are all about creating every exponential function imaginable. So what if I had 29 to the x? And I wanted to use e notation to write that. Then it is as follows. E to the ln of 29 raised to the x, which is times x. Now, I need a calculator for that one. I got no idea what ln of 29 is. I can find the ln of 27 and the ln of 32 quickly, so I can get a guess. But you want some exact answers here, right? That does it. Not that anybody, I don't know where you'd use that kind of, well, every exponential function can be written as doubling or tripling. So here's a graph. All right, I want to double. I go from here to here. And it takes a certain change in x. Well, what if I went out further? My change in x just grew, and now I'm a 3 to 1. What if I went out further? Well, now I'm 4 to 1, right? So every exponential function can be written in an infinite number of ways. I just wanted to give you a sense of a topic we didn't spend much time on, but hopefully just seeing this, maybe. You got 4 terms. My suggestion is try factor by grouping. So we'll group that one. And that looks like I got A times C plus D. And then we group this one, and it looks like I have B times C plus D. And then I hope you give some thought that there are 2 things times C plus D. What are those 2 things? Oh, yeah. A and B are getting multiplied times C plus D. Okay? All right. So, squaring these, 25 and 25, we're going to get 50 as a denominator. There's something I can see from patterns. But let's do the conjugate. 5 plus 5i. I sounded like NPR. Let's do the numbers, marketplace. 5 plus 5i. All right, going to have to do that right here with the help of the eraser. So 2 times 5 is 10. And why don't I do this a little differently? Can I? Nah, I can't. So 2 times 5i is 10i and 15i. I am going to take a shortcut there. I think everybody sees that. And then I have plus 15i squared. So what's 15i squared? Negative 15. So I'm going to use the eraser. So negative 15 plus 10 is minus 5. The denominator, middle terms cancel, and I get 25 minus 25i squared. So there's your 50. And I hope everybody can see that we should divide everything by 5. Minus 1 plus 5i over 10. Okay, let's get a quick sketch. X squared, 0, quadratic term. Positive 2, linear. Positive 6, okay, extending. Positive 6, cubic root. Big number in, big number out. Positive. Cubic root, a little bit of a, the reason is if you take a half, right, in a linear function, y equals x, a half equals a half. But in y equals x cubed, if x is a half, then a half times a half times a half is an eighth. That's a lot less than a half. Okay, that's why you get this kind of picture. All right, so this was a linear, and then a quadratic, and I want greater than 0. Oh, too bad, I got a lot to write. Negative infinity to 0, union 0 to 2, union 6 to infinity. Okay, out of room there, so just stating that. It's on your answer key that I sent you. I hope I'm doing them. Well, I am going to copy this, so it should be. Oh, then I got to write it down, because I'm not going to do this during faculty meeting anymore. So there's some room. So negative infinity to 0. I wish I'd put equals there. I'm tempted to. Union 0 to 2. Union 6 to infinity. There we go. Well, I have time to get I got time to get this done. All right, we should be able to just take a peek at this as a graphical. I want to do one for you graphically. I'll erase it. So what do I see in this? I see 18 is an asymptote. I see e to the x. I see using 4, and I see using 5.1. And if I use 4, I'm going up 3, so that takes me to 21. And if I use 3 times 3, that's 9. 9 and 18 gets me 27 for a height. I want 51, which is up here. This one we said was 5.1. This is growing. This is exponentially moving. So I'm going to be in the vicinity of 5.4-ish, I think. I don't think it's going to take much change to do that. This is changing by already 315. I might have botched that. This was a jump of 3. So 3 plus 18 is 21. So that was 21. That's what I guess what I wrote there. And then 9 plus 18 is 27. That's what I wrote there. Okay, so that's only a jump of 6. The next jump would be 18, but I've only changed by, anyway, let's do it out. I think it's a little bigger than what I estimated the first time. So subtract 18, 41 minus another 10 is 31, plus 2 is 33. Divide by 3 is 11. Now I want the ln of 11, and I'm going to add 4. Now, how can I estimate the ln of 11? Well, let's estimate the ln of 12, which is 2 squared times 4 times 3, e to the 0.7 to the 2 is 1.4 plus 1.1. 1.4 plus 1.1, oh, 2.5. 2.5 plus 4, 6.5. Yeah, I thought it would be bigger. So this is a little bit around 6.2, 6.3, but you need a calculator. All right. So this is an Algebra 1 problem, as long as you understand to put it in exponential form. Did you put it in parentheses and square? Otherwise, you would add 2x squared. You need 4x squared. So 4x squared equals 7. I'm going to do that over here. So x squared equals 7 over 4. We only have bases that are positive. So I don't need to say plus minus here. So x is equal to, trying to get this done so I can upload the video. So x is equal to the square root of 7 over 2, taking the square root of that. Okay? All right. Pure mechanics on the next problem. Pure mechanics. So ln, the inverse of ln is e to the 0, we know is 1. Why did I write 0? E to the 0 is 1. So x is equal to minus 1/2. Just going to finish these off. Addition implies I keep saying that, but this would be a good one to look at. Yeah, very quickly. Log x there, where a 1 gets us a 0. And then over here, same picture, but at 99, 100 gets us a 0. And we're going to add these two graphs up. Slow growth, right? Slow growth, but it doesn't take long. Like out here at 100, I'm already, in this function, I'm already at 2. So my answer is probably on this side of those two graphs. But yeah, anyway, I'm just playing. So log base 10, I'll put the 10 here in case people didn't realize this was a common log. X squared minus 99x equals 2. So therefore 10 to the 2 is 100. Put it in exponential form. I'm going to move the 100 to the left to set it to 0. And I've got x squared minus 99x. My 100 becomes minus 100 on that side. And so we got ourselves x minus 100. Boy, did I botch that. Times x plus 1. Because I thought the answer was going to be on the left side of the graph. I'll go back and look at my own video later, sort that out. So the only answer right here is positive 100. Okay, we plug it in. What do you put on top of the 10 to get 100? Well, that's a 2. 100 minus 99 is 0, is 1. And what is the exponent you put on top of 10 to get a 1 is 0, and 2 plus 0 is 2. So I'm definitely going to go back and do that on my own time, on my own dime, not yours. Because there's something there that didn't compute for me. I want to find out why. All right, so 1/2 is e to the negative 0.7. And we're going to put negative 0.7 up there with the t. So this is 100 e to the negative 0.7 t over 100. And we talked about 007 in the last test. The only thing I did was made a reciprocal. So 100 e to the negative point. Yeah, he was at our graduation there. Roger Craig, is that his name? He was at our graduation 4 or 5 years ago. Got to sitting across from him. He and his wife were over there. Somebody graduated. Anyway, I didn't see anybody coming after him from Spectre or anything. I had my eyes open. I was trying to cover his back. I was ready. I was ready to leap into action. I just erased the problem, the next problem. Number, that was stupid. What do we got? 59. Oh, have 100 pounds of uranium. Okay, you start with 100, you have it. Based on time, what are we doing? We got a starting date? Yeah, minus 2050. And what else we got? How long does it take? Every 50,000 years, that uranium crap. Oh, bad stuff. Bad stuff. All right, little work with negative exponents, some straight algebra here. All right, so remember x to the minus 3 is really 1 over x to the 3. So what you thought was multiplication is really division. So I'm going to move the negatives downstairs. So that's going to give me 3 and 1 make 4 down here. And then I'm going to move that one upstairs because dividing by 1 over y to the 7th, dividing by 1 over y to the 7th is really multiplying by y to the positive 7th. So that's going to be y to the 8th. We got a 4 here. So I'm going to make that look more like an exponent. And now we got minus 2. So I'm going to flip this thing. I'm going to put it over here so I don't lose track of it. So that's going to be 4x to the 4th over 3y to the 8th. So therefore I just flipped it, took the reciprocal, and now I'm going to square. So I'm going to erase this so I got some room. So that's going to be 16x to the 8th. And that's going to be 9y to the 16th. I hope that's getting, you're doing all right with those. All right, so we got ourselves no sign change. I am going to do a chart, sign chart, but I'm making my own sign chart because I'm going to put a dot there. Textbooks wouldn't do that, but I'm not, because I know signs aren't going to change there. In negative 4, there is going to be a sign change, and at positive 7, there's going to be a sign change. So I put a really big number in, I get a positive fraction. I put 1,000,000 in here, I get a positive. So that's false, which means that's going to be true. No sign change, that's going to be true, and that's going to be a sign change. So it looks like I've got negative 4 to 1 union. Why don't I put an equal sign there the next time? Yeah, anyway, it would have been a better problem if I put an equal sign and made that the square, because then you couldn't divide by 0. Would have been a better question. I'll remember it for the next time because Matt keeps telling me repetition. is our friend. Union, where the hell am I? 1 to 7. All right, now I'm going to shut this off real quick because I got to get this uploaded. And if I lose it, all this work goes down the tubes. Bye-bye.